Well, my name is Israel. I'm not from Israel. I'm actually from Venezuela. So a little bit more about me. I'm a tech lead at Careem. Careem is like cargo in the MENA region, focused on the Middle East and North Africa. I'm Venezuelan, but I've been living in Dubai for the last 4 years. So you can imagine, I have some funny stories with immigration already. My name, Middle East, Arabs, you know. That's my Twitter. I sometimes post interesting things. Other than that, it's mostly bad words in Spanish and pictures of my cat. And well, that's my blog. I try to blog once a week. I just try, but the intention is what counts. So what we're going to see today, we're going to go through the Pareto principle, which I think most of you are familiar with already, but let's just review it and see why it's important. Then we're going to see a simple Django project. Let's say I have a personal project, how the architecture looks like from the deployment point of view. I should probably have started with this. Django in the real world, this talk goes around scaling Django from a monolithic application point of view. We all know that microservices are trending today, but not always microservices, going to microservices is the right solution. It will depend on your scale, and also going for a microservices-oriented architecture introduces some complexities you don't want to deal with if you're a small team. So that being said, after that, we're going to see some tools to measure and have some visibility inside what's happening on your system. And after that, we're going to go through the most common bottlenecks and how to tackle them. So it's not a recipe. There are some good practices and recommendations I've seen at work and I've done myself. So yeah, basic concepts, the Pareto principle. Who can tell me what it states? Yeah, 80-20. Basically, the Pareto principle says that for many events, roughly 80% of the effects come from 20% of the causes. In the IT world, this means, for example, 20% of the code will produce 80% of the bugs. Or 20% of the code will produce 80% of the performance issues. This is important because this helps us prioritize what we should tackle first. If I manage to find that 20% that will give me an 80% gain on my performance, that's where I should focus. How do I identify those 20% issues? Well, oh, sorry. This is how initial Django deployment would look like. It's usually you have a front-end Nginx, Unicore or USG, depending on how lazy you are to set up USG. Usually, I deploy personal projects, and having that granularity on configuration is not important to me, so I just drop Unicorn there, then Django, and well, you can have a separate instance for your database. But these are the usual components, or the usual initial components. So how do we identify that 20%? We need to profile first. We don't jump in and start optimizing here and there, hoping that something will improve. We need to gain some visibility inside our application and see where the pain points are. So to do that, there are a lot of tools we can use. For example, there's django-debug-toolbar. This works as a Django plugin, and it's something I would recommend everyone to add to your project dependencies, at least to your development dependencies. It fires up a dashboard like this one, and it analyzes, for example, which queries were run by this view, which templates or sub-templates were rendered, if the cache was hit or not, the cache misses, and this is one of my favorite features, which is the database view. It lets you run the select that happened in that view, and even run an explain in that select to see how the query planner how it ran actually on a low level on the database. Now, on the Python side, if you want to profile your code, there are a lot of profilers. I personally used cprofile, but it spits a CSV text file, which you can pipe into Snakeviz, and you can have this kind of visualizations like sunburst diagrams and so on. But if using two different tools for a single purpose is too much, you can also use vprof. It's a profiler plus, and it includes the visualization tool. You can have code heat maps. It highlights each snippet and marks how long it took to run. You can also produce these flame diagrams, which a stack of your calls and how long they took, and even memory profiling. But if you have some budget and you want a production level tool, I will highly recommend you to use something like newrelic or Datadog. I personally used newrelic, and on the dashboard you can see not only the response time, but on which part of the application the time went on. For example, how long it took for the database to reply, how long it took to the application for the application to actually run, how long it took for the cache to reply, and so on. It also lets you see the transactions. If you drill down, you can even see a breakdown of where the time went and what happened. And if you continue drilling down, you can even see the queries being run. So you can then run and explain on MySQL or Postgres. So the first pain point you're going to face is the database. Usually you have a monolithic database. And you could argue that maybe you can do data sharding or federate your database and gain some performance there. But when you start having distributed transactions, that also adds complexity to the process. So before going distributed, try to optimize whatever you have at the moment. And one of the things you usually want to do is reduce the amount of times, the number of times you go to the database. You want to do as a few queries as possible. So here is an example of an ORM expression with a problem. Who can spot the problem here? Who is? For each strip, it will go to database to do the query for customer. That's right. So here, for each return trip, it will hit the database again inside this loop in line number 5 to fetch the customer to get the name. So what's the solution for that? Yeah, something like that. For this, since it's a one-to-many relationship, you can use select related. This will join the two tables together and return everything in one hit. So when you get into the loop, all your records are there, plus the related data, so you don't need to go n times to the data, n+1 times to the database. So in general, to reduce the query count, you want to use select related for one-to-many relationships. Whenever you have one model related to many others, and prefetch related for many-to-many relationships. Prefetch related will retrieve everything using only three database queries and join everything in Django level. Another thing you have to do is you need to always use your tools wisely and measure. For example, here we have an example using select related. It's getting a customer with all its related trips. And if I do customer.trips.all, it won't trigger another database query. But if I try to filter, if I'm interested only on the trips that were canceled by the user, it will trigger another database query. Why? Because the query set that was evaluated the first time is different than the one I'm asking for. So it needs to go to the database, fetch the new result set, and give it to the application. So sometimes, and depending on how much data you're returning and how big your database is, sometimes you want to take advantage of the cached query set and just do an in-memory filter. So if you're interested only on the trips canceled by the user, you can use list comprehension over the cached query set, and it should be faster than going again to the database and retrieving the new result set. Always, you have to measure. Another way of reducing the query count is using the prefetch object. Here, we're declaring a query set. It's getting me all the expired subscriptions with the related trips, the trips that happened within that subscription. So I use the prefetch object, and what the prefetch object does is it pre-filters the information instead of having to do it within the second query set. It prefetches it pre-filters the data and just dumps it into the prefetch related expression. So on line 10, I'm actually retrieving all my products with expired subscriptions for the location Lahore. So if I do product.subscriptions.all, it will that filter expired. It won't go to the database again because that's already cached. We will probably see more about cached queries on my talk on day after tomorrow, or probably today because there's some talk about query optimization later on. So I'm not going to go too deep into this part. So now we reduce the amount of queries we're doing. Now we want to spend as little as possible in the database. We want to reduce the query time. If a query is taking too long, what do we usually do? Yes, we cache it. But if we actually have to go to the database and the query takes long time, index. Adding an index in Django is quite straightforward. It's just adding a keyword argument to the model field. Knowing where to add the index is the tricky part. And this is important because your database management system will update the index on every write or on create or on update, on insert or update. This means if depending on how long your index is, it could take a long time to update, so your write performance will be affected. So some notes on indexing or some good practices. You need to measure before you add the index. You only need to run and explain. And you basically need to look for a sequential scan with a lot of records in the result set. You need to index by workload. If you filter for more than one field, those fields need to be in the same order in the index. And you can use the index to get a meta option on the model. After you add the index, you need to see if the index is going to be used. Sometimes the query planner finds out that a sequential scan is still the optimal way of retrieving the data, so it will choose not to use the index. So before pushing your code and deploying your code to production, just run and explain again and see if it's doing if it's using the index to retrieve the data. Now, expensive joins. Whenever you're joining tables together, both tables need to be loaded into memory. So if you're loading potentially huge tables, that could take a long time and hurt the server performance. So sometimes, maybe 2 queries are better than just one. For example, the query set in line number 2 is basically retrieving all the credits used, all the credits related to a trip for the location Jeddah. So my credit table creates a record for each credit consumption. My subscription table has 1 record per subscription to a product. And my trip table has 1 entry per trip. That could be a lot. So sometimes maybe I can just retrieve the subscription IDs first, and then feed that into a second query to actually get the credits. As always, you need to measure and make sure that there's a performance gain by doing these optimizations. Another thing to avoid is the whole table counts. For example, trip.objects.count. When you reach certain scale, having exact numbers won't actually matter. If you have a classified website, for example, and you're computing the number of listings in one section, no one's going to count all the listings and see if it matches. Plus, it's always changing. And it's overkill for the server, it's overkill for the database system, and actually your database system keeps record of this for you. Instead of computing the count all the time, you can just use query the information schema, either in Postgres or MySQL. It will be off maybe for a couple of thousand records, but for count, for example, the number of trips, the total number of trips you have done, or the number of listings on one section, assuming that you have 1 table per section, won't matter. Don't use this if you need actual numbers. For example, for something like rate limiting or credit accounting, I wouldn't recommend this. Just go for proper counts. But for table totals, you can easily query the information schema, and this could lead up to a 90% improvement in the response time. Starting in Django 1.6, I think, or 1.7, they added a feature to keep the connection to the database open. When you're opening a new connection to the database, just starting the connection is the most expensive part. All the TCP handshake, and it takes time. So they added this feature to keep the connections open. If you set it to none, it will keep the connections open forever. I wouldn't recommend that. If you set it to a number greater than 0, it keeps the connection open for that number of seconds, and then it closes it and it opens a new one. And it actually increases your performance a little bit. If you set it to 0, which is the default value, it just opens a new connection and closes it per request. That's the normal default Django behavior. So, in summarizing, you need to know your ORM. You need to read the full ORM documentation at least once. Don't do it every day, do it at least once, so you know what's there and what's not. If you need to reference fields within the same query set or within the same record, you can use F expressions. I'm not going to go deeper into this in this talk. For more advanced filters, Q expressions lets you modify the default Django behavior of ending all the all the filters. If you use Q expressions, you can add or XOR or more complex filters. Explore the aggregation framework. If you need to produce reports or add or use database level functions, Django comes with a really powerful aggregation framework out of the box. You only need to go through the documentation and use it. If the data you're returning is too big, so the memory trade-off is the memory overhead of fetching the data and loading it into models is too high. You can just return few fields or return what you need. For that, you can use values list only, or defer whenever your results are too big, your actual models. Another thing, and that's this part is not related to Django. This is mostly this could apply to any database, ORM, or any web application. Maybe denormalizing would be a good thing. For example, if you have huge joins and you're constantly joining two big tables just to get the value of one field, maybe it makes sense to denormalize that field into one of the two models, the one you query the most. This is some sort of database level caching if you want to see it some way. And Django has the concept of generic relations. This lets you link models, any model to any other, without specifying the physical relation. This is bad and shouldn't be used in production. This is a graph from newrelic. Before the deployment, we were having a generic relation between two models. And we found out that we were spending a lot of time in the database. When we drilled down, we found out, oh, here is why. It's querying the content types model, which is a Django internal, and that's what generic relations are based on. And then it's querying the actual table, so that's where the time is going. We denormalized that generic relation, and we managed to lower the time from roughly 600 milliseconds to below 100 milliseconds. As usual, just measure and monitor your application. You can also query your cache query sets. These two projects are kind of abandoned, but I don't know if someone is maintaining a legacy application and they need to cache the query set values. So Johnny Cache and Django Cache Machine, they both work on the same concept. They just add a caching middleware, and whenever whenever there's data returned, they just cache that response. And whenever they need that specific query set again, they don't go to the database, they just get it from the cache. There's a gotcha on this. Since it works on an HTTP level, if you manually change a record from the Django shell, it won't refresh the cache because it didn't go through the middleware. The middleware is like the smart part of it. Now, your second pain point is going to be templates. For this, on the Django side, there's not much to do. It's all about caching. And one quite efficient technique I've seen is the Russian doll caching. It's basically it revolves around the TTL of the cache. For example, if you have a blog, and I'm going out of the trip and sorry. Domain, because Careem is mostly a mobile app, so we don't do a lot of templates. So let's say you have a blog and you want to cache your sections. You can define a slightly lower TTL to the external part, to the header and the footer, to kind of the parent template, and longer TTL for each one of the articles. Why is that? After you publish an article or a blog post or a classified listing, chances are it won't change that much. So you just cache it longer. But you will have posts or listings added every, I don't know, depending on the traffic, maybe 5 seconds or 10 minutes. So the whole page is going to change. So you cache it for a shorter time. So when you have to recompute the whole page, the blog posts or the items that were already there are cached, and there's no need to fetch them from the database. It will just fetch from the database the new ones which are not cached yet. So further optimization. And these ones are quite standard. Minimize and compress your CSS and JavaScript. For that, Django compressor, web assets, or Django pipeline are Django packages that are out there. You can just install them and use them. Optimize your static images. The static images and the web assets are under your control, so you can optimize them so it doesn't take forever to download. And try to optimize your user uploads if you have user uploads. Serve your static media from a CDN. That's quite a common practice. And defer slow work. For example, optimizing your user uploads is something that could potentially take long time. So you can use something like Celery or Python RQ along with Redis or RabbitMQ to have and do it on the background without having the user to wait for a response while the image is processing, and potentially the connection could time out. And on the database level, if you have a lot of traffic and a single server is not enough, you can use read replicas and database routers, so it's transparent for the programmer which database is being used for reading and which database is used for writing. This will redirect the read traffic to one instance and your write traffic to the master, and the master will update the slave. So when optimizing, you don't want to rush in and just do random optimizations here and there. It's a process, and it's something that you should do according these two great software engineers slowly. Despacito is Spanish for slowly. Just don't rush it. Measure, take your time, and and then take action and implement it. So I think we have 7 minutes for questions.
Anyone from the audience? Any question? We can skip Slido. Raise your hand. All right, let me get you a mic.
Thank you. Thank you for the presentation. You said we should not use generic relations, but sometimes there are some particular requirements where we have to use some kind of generic relations. Is there any alternative to it? I mean, instead of if I have to use something where I have 1 to 3 models on the one side, 1 to 3, and they can be related to A, B, C, any one of them. So I need some kind of a generic relation. So I use the content types framework, or is there any alternative to it which is faster?
If there's a specific use case where you need generic relations and there's no other way around, because I'm not aware of any Python or of any Django module to optimize the Django relations. You could rely on indexes. You can rely on normal database optimizations, but it's a case-by-case study. We can just take it offline and grab pen and paper and see what we can do.
If there's no more questions, I have a question. Do you have anything to recommend in case you have a service-oriented architecture with Django, something to create content types as a service? Has anybody ever done this?
Define content type service?
Something that provides, an ID for each table or each model or each structure in the entire service architecture?
I don't think I get the question.
Okay, maybe the use case is weird. Okay, never mind. There's a question.
Actually, to tie into what you just said, one interesting question that we have is when you have multiple Django applications, which are like microservices effectively, how do you connect them without necessarily using a foreign key which directly ties two applications together?
Okay, if you have independent microservices, and well, this is a little bit out of the scope of the talk, but if you have independent microservices, they should be self-contained, meaning that they shouldn't be sharing any foreign key or any primary key. They should talk to each other in the most common scenario through REST APIs. Although, well, I think I'm going to give a lightning talk on microservice architecture and 10 guiding principles I personally follow. But summarizing it, they should be self-contained. They should talk to each other through REST APIs if they need real-time updates. Otherwise, what I recommend is they should trigger events, and those events should trigger updates on the other microservices interested in that event. But databases, caches, everything should be microservice specific, meaning that they shouldn't be sharing any resource so they don't step on each other's hosts.
We have a question on Slido. So why are you using GUnicorn over UWSGAI? Can you explain the difference?
Yes, I'm using Unicorn over USG because I said it on the presentation. I don't need that small granularity on the configuration. The difference between Unicorn and USG, USG is to say it on a high level. USG is more configurable, and you can achieve better performance by finely tuning the configuration parameters. While Unicorn is a more out-of-the-box solution, you can just tune the way workers behave.
Okay. If there are no more questions, there's one more question. Okay. What about this one?
Is there any provider that can be attached at runtime to limit overhead?
Can you read it aloud?
Yeah. Is there any profiler that can be attached at runtime to limit overhead once the app is running in production? I've seen some implementations of middlewares running cprofile. I think there's a Django. Sorry. I think there's a Django module that does that. However, if you have budget to spend on monitoring, I strongly recommend New Relic or Datadog.
Okay.
It will not only give you the metrics, it will also give you all the visualization, and you can create your own dashboards and aggregate metrics and a lot of fancy stuff.
Okay. Thank you very much.
Hi, my name is Israel. I just finished my talk, Django in the Real World. It was about optimizing Django for production environments. It went quite well. Basically, I like to speak at PyCons and attend as many PyCons as I can worldwide, because one of the Python mottos is come for the language and stay for the people, stay for the community. So I try to meet as many Python communities as I can worldwide. And since it was the first PyCon in Serbia, and I ran the first PyCon in Venezuela, I know how it's like to struggle to find good talks, struggle to find speakers. So I wanted to kill two birds with a stone, meet the local Python community and speak at the local PyCon.